Hello, and welcome to a Novatech Instruments presentation of their Model 409B DDS signal generator. In this video, we will demonstrate some of the key features of DDS technology, which stands for Direct Digital Synthesizer Technology, and how it can benefit the scientist and engineer when generating sine wave signals for system development. First, let's get acquainted with the device. On the front panel, there's an indicator light and 4 independently programmable BNC outputs, channels 0 through 3. On the rear panel, there's a power jack for the included 5-volt power supply and a DB9 serial port that accepts commands from a Windows-based computer running the included SOF8 409 software. There are also 2 SMA connectors and 1 BNC connector that support features not discussed in this video. One advantage of DDS technology is the ability to change frequencies in a phase continuous manner with no phase discontinuities. We will do this switching from 10 MHz to 5 MHz on the oscilloscope. This oscilloscope image is a capture of the 409B changing from 10 MHz to 5 MHz in a phase continuous manner while in phase continuous mode. It can be seen clearly that as it changes frequencies, there are no phase discontinuities. Another advantage of DDS technology is the ability to generate multiple outputs that are phase synchronous and can be made to be phase aligned. The 409B accomplishes this due to sharing one master clock for all output channels. This oscilloscope image shows 2 10 MHz sine wave signals coming from 2 separate devices running 2 separate master oscillators. The blue waveform is from the Novatech Instruments Model 2975AR signal generator, where the triggered yellow waveform is from the Novatech Instruments Model 409B signal generator. There is inherent drift between the 2 signals due to the fact that they are running on 2 separate master oscillators, which is an example of non-phase synchronous operation. We will do our best to try to synchronize these 2 waveforms. For the following demonstration, the precision of our frequency counter is within 1 part in 10 to the 11th for a 10 MHz signal. Let it be noted that the 2975AR's blue waveform is indeed accurate to within 1 part in 10 to the 11th. Our best attempt at dialing in the 409B to within 1 part in 10 to the 11th came to within 49 parts in 10 to the 11th as a 10 MHz waveform. Now, as we witness, there is still drift between the 2 waveforms due to the fact that 2 master oscillators are almost impossible to synchronize to the point of having 2 outputs at the exact same frequency. Therefore, they will remain in non-phase synchronous operation. We will now switch to 2 output channels of the 409B. Please observe how they are phase aligned and share the exact same frequency. This is an example of phase synchronous operation. Also, the blue waveform has the same output amplitude as the yellow waveform, but has been scaled down for observation's sake. Changing the phase of one channel so that the outputs are 180 degrees out of phase with one another, we see that the Model 409B retains phase synchronous operation. Now, if we rescale that one channel, we see we have 2 identical 10 MHz waveforms exactly 180 degrees out of phase with one another. This is during phase synchronous operation. Now, we can also change the frequency, and we see that the intersection points are exactly where they should be. Changing back from 5 MHz to 10 MHz, we see that the phase relationship is retained. In phase synchronous operation, changing one frequency to simulate quadrature operation is very easy to do. The Novatech Instruments Model 409B can also simulate 3-phase power. The 3 outputs are connected at 60 Hz, separated by 120 degrees. This is in phase synchronous operation. Thank you for watching this Novatech Instruments video. Please feel free to contact us with any questions and visit our website, novatechsales.com, for full product information and documentation.